In this video, we will discuss about BSS coloring, or also known as spatial reuse. Before we go in depth about BSS coloring, there is a concept that you need to know, which is CCI, also known as co-channel interference. Think of it like this. I have an access point that is working on channel number 1 on 2.4 gigahertz. I have another AP here that's also working on channel number 1 on 2.4. Client here talking to the AP. Now what this is doing is, when the client comes and talks to this AP, it sprays the signal or sprays the data in the air like with the Omni antenna. Okay, there is a possibility that a client sitting right here also heard this transmission. Okay, it also heard the transmission, and now this client thinks that there is somebody in my frequency. They both are on channel number 1. Now this client and this AP think that, okay, there is somebody already transmitting on this frequency of channel number 1, so I need to halt my transmission, which means it's because there is only one client or one radio can transmit at a time in a particular frequency, right, in Wi-Fi. So since they are of the same channel, their client, which is in a different BSS, this is a different BSS, it's a different BSS, even though they're in a different BSS, they still hear some RF energy in that frequency, and hence they will halt their communication, or nobody will transmit here. So effectively what's going on is, even though you have 2 channels available and 2 access points available, you are effectively using it as a single BSS, as in a single frequency space, which means now these 4 devices are in a single cell and only one of it can transmit at a time. Now this is wastage of one, or this AP is now completely wastage, right? In real scenarios, in practicality, this is not how things are configured. Things are configured something like this. Let's say an architecture is deployed like it's a multi-channel architecture. Like there's enough, there's going to be some overlap. Let me draw that once again for you. So this is channel number 1, 6, 11, 1, or you can name it as, you can give this as 1, you can give this as 11, and you can give this as 6. So what I'm trying to say is, in real scenarios, this is how channels are made, or APs are deployed. Now if a client on this, in this BSS is talking, it is still spraying the energy. There is a possibility that a client here in the same channel is still able to hear this transmission. It is possible. On 2.4 gigahertz that happens. So it is almost impossible to remove co-channel interference. It's not going to happen. It's very difficult to remove co-channel interference. Let me quickly try to fix this. Hang on. Okay, so with transmissions happening on BSS 1 and BSS whatever 3 maybe, for example, this client, when hears a transmission happening in this BSS, it will halt its communication because it thinks that in my frequency there is somebody else already transmitting and I need to keep quiet, right? Because one radio can only transmit at a time. Now this is CCI, co-channel interference. My co-channel is interfering with my transmission, so I'm going to keep quiet. Now this was a major issue in 2.4 and this has never been addressed. Okay, so now BSS coloring is an attempt to mitigate that. Now BSS coloring is taking care of, or is mitigating, overlapping BSS. Okay, now it is almost impossible to stop 2.4 gigahertz CCI, not possible. Client's transmission here is causing CCI. You cannot stop clients to transmit data. Okay, it's always going to be there. Now, as I said, BSS coloring is .11ax way of .11ax way of mitigating the OBSS. Now, how this happens is, whenever a client associates to an access point, okay, the access point advertises its BSS color to the client. Let's say its color is blue, for example. Okay, here another access point, when this client associates with it, this AP advertises red, for example. Okay, by the way, it's really not colors, it's a numerical identifier of the BSS, but we are going to take example of color just to make it easy for everyone to understand. Let's say my this BSS becomes blue and this BSS becomes red, right? Now, how OBSS is being mitigated is in BSS coloring. Now, if this client is transmitting, okay, this is called, let's think of it this way. There can be two scenarios. One is intra BSS, which means if my client is here and this client is communicating, when this AP hears the MAC address, it says, okay, the color seems to be blue for this BSS and my color also is blue because I am the part of same AP. I will think, okay, this is my BSS, transmission is happening inside my BSS, so I need to keep quiet. Client will hold transmission. Okay, just like it usually happens. If there's a client talking to an AP in my BSS, I have to keep quiet. This is intra BSS. Now, in the inter BSS scenario, where even though they are on the same channel number 1, if this client hears the communication happening with this client, it sees that, okay, I see a transmission happening, I see the MAC header, but this MAC header shows me that the BSS color is red, which is not my color. So I'm going to assume that the transmission happening is in some other BSS, not my BSS, and I will continue to transmit my data. Okay, so this is how you are completely mitigating the CCI, co-channel interference. Even though you do know that the transmission is happening on my frequency, but the BSS color is different than what was advertised to me by my access point, and I can assume that, okay, this transmission is happening in a different BSS altogether, it will not affect me, I can continue to pass my traffic. This is how BSS coloring is extremely essential and helps us to clear out CCI in a way in a wireless medium. Okay, so this was BSS coloring for you, and it is not a color, it is some sort of a numerical identifier for the BSS in the MAC header, right? Hope this makes sense and hope this is clear, because BSS coloring is an important feature of .11ax. In the next video, we will discuss about target wake up time and then we'll wrap up the chapter. Thank you.